How are you guys doing? All right. Excited. I'm excited to present. I love Fonzi. I've been showing up to a couple of the meetups that you guys host, and yeah. So, all right. Let's get started from the beginning. So, who am I? I'm Sebastian Sosa. I was formerly a member of the technical staff at Varus AI, and now I'm the founder of Noemica. And you can see on this link, it basically it has a bunch of supplemental links that you might might want to use. Okay, so today sure. Okay, today I'm going to be presenting user testing the user tester. What is the user tester? The user tester in this case is Noemica. Noemica is a system that provides synthetic user feedback against your environment, whether it's dynamic or static, through synthetic users. And I think that it is the best way to wrap your mind around how Noemica works is quite simple through this pseudo function signature that I'm presenting here, where on the left side you have Noemica as a function that takes in two parameters. That's it. One of the parameters is a URL. What this is essentially the environment that you're testing against. And then the second parameter is the study, what you want to learn about this environment. And then when you execute this function, a batch of users interact with your environment to be able to answer your question that you're posing in the study. And then as output, you basically get a list of user feedback and outcome pairs. So that's what Noemica is. When I first reached out to Fonzi about this talk, I proposed two different abstracts. The first one is your agent's users have thoughts, you just can't hear them. This was going to cover the different ways that you can collect user feedback and how you can implement them in improving your product and how that compares to synthetic user feedback. And then the second thing I proposed was basically tapping at the evolution in agent design, how formerly it was about adding more tools, but now it's mostly about reducing the degrees of freedom. What that means is constraining the agents so that they can provide a more streamlined solution to whatever it is that you're offering. Why I'm mentioning this is because a lot of time has passed since, and over the course of these 2 months since I initially proposed this, and now that I'm standing here, I've ran a couple of experiments, and I ran into this problem where I needed to know why Noemica was failing, and I knew that users were not getting what I was hoping they would get from using Noemica. And so I wanted to learn what the users were thinking. And it became obvious that I should use Noemica on Noemica. And then the second thing is that at the time, I didn't have validation. I didn't have metrics. I didn't have anything to tell me how users were using my platform. And so I couldn't form any informed assumptions about what was going on. And then the third thing was I was tired and I wanted to go to sleep. And this just happens. This happens every single day. And the only way to supplement this is through sleep. But I want my agents to be running all the time. So I wanted this to be completely automated. And hence the synthetic user feedback autonomous self-improvement loop. Or in other words, SUF-DASL for short, which we'll be calling the loop. Okay, so how does this loop work? Let me actually guide you through it. The top right represents the experiment, which is you don't need to look that deeply. Don't lean in. You can relax. You're just gonna get confused. So what's happening is the experiment is running Noemica on Noemica, so that I can get feedback on how users are interpreting Noemica. And the objective is to make sure that the users are able to walk away with something interesting about their whatever they're building. And that is a ternary. That is a binary case where either a user walks away with something interesting or they do not. And the objective, if the objective is met, then the loop terminates and it's over. You've already satisfied the objective of your study. Otherwise, all of that feedback that was collected from those participants is sent over to Claude Code. Claude Code tries to interpret what the participants felt and what might have provoked those issues, and it performs the necessary updates. That's what you see here on the left side. Then that gets handed off to the actor. And then what the actor does, it just continues propagating the loop. And to recap, it basically goes from the experiment, determines if the objective is complete. If it's not, it goes to Claude, and then Claude performs the updates, goes back to the actor, continues cycling until the objective is met. Now, what was actually mutable? What could Claude edit? And then the short answer is everything. It could edit the client, it could edit the backend, it could edit the agent, it could edit the infrastructure itself, and it could also edit the study design. Now, if you think back to elementary school and you think about the scientific method, there is this thing called the hypothesis that you're supposed to keep constant throughout your experiment. I guess I was too distracted trying to put like squares and like round holes, and I found that so compelling that I might have missed that point. And hence, Claude was able to edit the hypothesis of the experiment in the study design, which caused problems down the line, which I won't be able to cover, but you can look into afterwards. Then the other thing is I wanted this to be autonomous. I wanted to go sleep. And so I set up a skill that was stupidly simple. It essentially consisted of every 5 minutes, you're just going to tell Claude to continue no matter what. So if it needed any credentials or it had any questions, it would get interrupted with continue no matter what. And that's what it did, and it never stopped. So now we actually kick off the loop. What happens? Oh, and so this is actually the more detailed representation of how the loop worked. But in short, what it's saying is that Noemica is running against Noemica with the objective to see if any participant can learn something interesting about their product using Noemica. And there was a lot of real problems that were solved. And basically, in each one of these 9 iterations, which I'll have. So through these 9 iterations, in the first 9 iterations, it did not reach the objective. It was only until the 10th one that it reached the objective and it closed. A participant was actually able to discover something interesting. But in those initial 9 iterations, it uncovered real bugs and real issues that users would have ran into. And as a complement to each of those real bugs, Claude produced fixes with a good degree of variance. Some of the fixes were exceptional, others were crap, and some were like outright vulnerabilities. And in spite of all of that, there are some really interesting takeaways that I want to share with you guys today. So the first one is that on the very first iteration, the first couple minutes of running, one of the users was able to uncover a very blatant bug. And I'm just going to read it out loud, what Maya said on iteration 1. The browser tab closed on me mid-wait, which was a bit annoying, but I navigated back without losing anything meaningful. The report isn't ready yet, and blah, 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 blah. This was sent back to Claude, and Claude discovered that the problem was that the infrastructure was essentially timing out on the participants. And so Claude fixed that, and the loop continued. Notice how this is the kind of ticket that you could get by either running a week-long or multi-month-long study, like an actual formal user study, or you could alternatively get by some of your users being generous enough to like go to a forum and inform you about the problem. And that's probably going to come at the cost of already losing a lot of conversions. And here's what basically that looked like on Noemica. You can see how she's just sitting there waiting patiently for the study to conclude, and then the browser just dies on her. And so the study was over. The next takeaway that I want to cover is that if you don't enable your agent to ask, then your agent will just hack through whatever the solution might be. So in this case, Maya informed Claude of another problem, and it read as follows: still no verification email after a couple minutes of waiting. This is getting a bit annoying. ... From this, Claude Code inferred that the problem was that staging did not have the acquired functionality to actually receive the emails for authentication. And this essentially grinded the loop to a halt. And Claude basically thought through three solutions. One is ask me for the credential to provision the service, provision the required services to unblock this problem. And of course, I'm out of the loop, so that's not an option. Option 2 is it can automate my browser and retrieve the credential itself. And if anybody has used browser agents, you probably know that this can take anywhere between 10 minutes or a couple weeks to figure out. And option 3 is hack your way through the problem. In other words, eliminate the email authentication altogether, which in a sense, it's transforming this into a ship of Theseus. It's no longer testing Noemica, it's testing a different version of Noemica, which is I'm not interested in. And as you can imagine, Claude, in all his wisdom, knows its limitations, and it chose option C. And in short, and this again is evidence of what Maya ran into. She was trying to get authenticated, and she waited a couple minutes and eventually gave up. So that was the second takeaway. Now for the third takeaway. This one is a bit higher level, and that's that if you're running user tests, then they operate completely independently of the code base. Meaning, user tests are oblivious to your code base. And I don't know if you've been paying like very close attention to the presentation, but I've been using production and staging interchangeably. That is not because I'm messy, but it's actually because that was what was happening. Iteration 1 through 4 was in production. Iteration 5 and onward was on staging. What this means is that, well, one, I didn't notice until I looked at the audit that I basically shifted the entire underlying code base underneath the loop's feet or whatever, and neither did Noemica and neither did the loop. Nobody seemed to care. Nobody seemed to like raise any objection to it. And what this basically drives home is that user testing is more robust than the alternative methods of unit tests, integration tests, end-to-end tests, where if you change the underlying code for these tests, you need to refactor the tests as well. With user testing, and at least in what I was testing in particular, trying to get a user to learn something interesting with their code base, I did not have to change the experiment at all. Now, after all that work, it finally, like, the results were kind of extraordinary. It went from not being able to get past the first step to getting through end to end, and every single participant discovering something interesting about the environment. This is actually a lie. In fact, this was iteration 0. Noemica was working from the very beginning. It was fully functional, but functional does not imply anything about it being useful. So you might be asking, what was it doing in all those 9 iterations? It was discovering issues that would have otherwise killed your conversion rates before anything went into production. So if I can leave you with a couple takeaways, it's that synthetic user testing is sufficiently accurate and sufficiently faithful to what your users are going to discover that it's incredibly useful. So let me repeat that. Synthetic user testing is sufficiently accurate to be incredibly useful. And then the second thing is autonomous self-improvement loops are incredibly powerful, but powerful is a magnitude. It can either be powerful at causing regressions, or it can be powerful at making improvements. And that is contingent on how you constrain and how you design the system. And if you put those two together and actually design things correctly, you can get some magical results. And now, as for this QR code, this basically has all the supplemental resources. And additionally, I'm going to be opening up an API, and I'm going to be opening up an API sometime in the near future. If you guys are interested, there's an application to be pilot testers, which I'm going to be opening up. I'm going to be opening up the pilot testing next week. That's it. Thank you, and I'm open to any questions.
Okay, cool. Hi, everyone. My name is David. I'm a software engineer at Hebbia, and we help the largest financial institutions in the world analyze data across hundreds of thousands of documents all at the same time to be able to make well-informed decisions. I've been there for about 5 months now, and I'm going to talk about our experience and our story building background agents. Before I get started, can I get a show of hands who uses coding agents every single day? Okay. And how many of you have at your organizations built a custom coding agent specifically for your developer environment? Okay, cool. And how many people are doing like B2B, enterprise, SaaS? Okay, cool. Okay, great. I just want to get a lay of the land. So essentially, background coding agents are becoming more and more prevalent in the tech industry. A lot of the top companies, such as Stripe, Ramp, and Coinbase, they've been building these for months now. Stripe, they said that their minions are shipping about 1,300 PRs a week, which is absolutely insane. Ramp put out an article on their agent Inspect, which is shipping 60% of the code that engineers are shipping. Again, bonkers. And Coinbase they put out a report saying that work that would have taken about 12 weeks has been cut down to just a matter of days. This is the power that AI coding has allowed. And the reason why these background agents are so important is because it allows you to essentially build a bot that is specific to your own developer environment, because not every single company has the same infrastructure. Some companies are using monoliths, some people are using microservices. There's so many different ways. And unfortunately, if you play around with Cursor, Claude Code, all these platforms, they say that you can use a sandbox to work on your tasks behind the scenes, but your dev environment has to be very, very, very specific. So at Hebbia, we've experimented with this. So we built this bot called Striker. It's a cute little, I don't know why he's a frog, but he was just a frog. And essentially, what this bot was a cute little Slack bot that we could use in Slack, GitHub, Linear. Essentially, what you could do, you could tag it in a channel and say, hey, can you go and check out this front-end bug? It will spin up a sandbox, write some code, open up a pull request. It had MCPs to Post-Hog, Datadog, whatever you needed, launch.glee. And then whenever we had any sort of questions, it was able to easily use those MCP servers and answer the questions in a timely manner. And it was great. It was working. Everyone loved it. But we quickly start to see the limitations of the way it was built. And that was because essentially the way it worked behind the scenes was that we had this bot that you can tag in Slack, and then it would spin up a result sandbox that ran an open code server for every single request that you made. So you would initialize it, it would spin up a sandbox, an open code session, and then your conversation was just in that session. And then eventually we'll make a pull request. It was great, but then the problem is that when you're spinning up multiple of these sessions, how do you actually go and test your code? A result sandbox is not enough to run our entire backend. It's not, and we all know Vercel, they've been having some issues lately. And unfortunately, our bot was deployed on Vercel, but luckily we weren't affected by this, but it opens up a question of like, okay, well, what do we do so that we don't get affected by situations like this? So for everyone who's not aware, Vercel had a security incident where someone was able to hack into an employee's Google account, and they got into the Vercel system and they were exposing environmental variables of different companies. And if you're making a bot that has all these different tokens and you're storing those environmental variables in Vercel, they can get exposed, and there's so many different things that could happen from that. So what do we do from there? We essentially switched to using a platform called coder.com. And essentially what coder.com is that it allows you to make the cloud dev sandboxes for everyone on your team. And they've recently added an AI element to it. So now you can actually just spin up a coding agent in your own cloud environment that is exactly the same as the developer's dev environments. It's hosted on the front end. It runs our front end, our back end, our databases, everything, and it's all in one session. So you start off a session, it spins up a container, you do whatever you need to do. After a certain amount of time, the container dies down. So this is way more secure because the nice thing about this is that it's all within our AWS environment. So we don't have any issue. We're not necessarily worried about things getting exposed. I'm going to talk about the 3 lessons that we learned in between these few different agents. Point number one, just run the stack. Number 2, hard guardrails. Number 3, make humans effective. Now, lesson number 1 is that if your agent can't actually test your code, every single pull request you make is fiction. Nothing is real because the agent is just doing whatever. Can I get a show of hands who prompts their Claude Code agent and it gets the code perfect every single time? Yeah. I know you don't. But exactly, nobody does. And if you do, I can shut this whole thing down and you can come and talk for the next hour or 2. We would love to hear from your perspective. But the truth is that doesn't happen. your bot will make mistakes. Now, how do you actually verify those mistakes? In the old system, what we had to do was that the bot would write some code in a Slack thread. When it's done working, it would say, hey, my stuff is ready. Then you got to go switch and wait for the preview environment to be done. Or if you don't have enough time, you got to like pull it locally and then test it. And it's just like a very tedious process. I had to do this for every single time the agent made some code changes. But in the coder instance, it was nice because all we could do is just tag it. It would write the code, and right there in coder, it spins up a local front end and local backend right there. So it'd be like working on 5 different computers at the exact same time. So there was no context switching. Once the code was done, the servers are running, the backend is running, the front end is running. You can instantly test what you need to test, and then from there you can make a pull request. Now the second thing is guardrails. So guardrails are, when I say guardrails, I'm talking about things that you don't want your agent to be able to do. People tend to rely on prompting. People think that they're the best prompters in the world. And prompting has only been around for like less than 3 years, so there's no way you're a professional prompter yet. Now, how do you actually solve for that? The best thing that I found is to just not give your bot permissions. And as devs, as AI devs who are trying to push the boundaries of what we do, you want to make a bot, what access do you want? I check every box, write, read, delete, do whatever you want to do. I'm going to prompt you to not do certain things. And that does not work. If you don't want your agent opening PRs, the GitHub token you give it should have the access, the ability to open pull requests. If you don't want your agent touching your production database, don't give it any sort of route to even get there. People tend to hope that the prompt works, and it's a pipe dream. It just doesn't work. And no matter how smart these models get, your best course of action is always going to be to not give your agent access. This is my dog. He's very cute. His name is Louis. He's about 5 years old. And Louis loves to lick everything. When he was younger, he used to chew a lot. And these are some very expensive shoes that I bought that I'm embarrassed to say how much I paid for them. But if you know, you know. Now, if I don't want Louis to eat my shoe when I'm not at home, I'm not going to be like, oh my gosh, Louis, you're such a good boy. Please don't lick my shoes. Don't eat my shoes. No, he doesn't care. Once I leave, and he sees the red in the corner of his eye, I'm going to come back, and shoes that cost thousands of dollars, they're going to be absolutely destroyed. I know he's going to do is look at me and then want to go outside and take a piss. So the solution is put him in a crate. The crate's locked. He can't get out. He has no access to the shoe. And that's essentially what sandboxes are for your code. It's just a crate for your code, so that how you configure your sandbox depends on what your agents actually have access to. I know we have a tendency to run Claude code in like a dangerously bypass permissions, and I'm just do what and full send it. But when you're working with enterprise customers, when your bot makes a mistake, that's a lost contract. That is credits you have to give. That's thousands of dollars in refunds, and that's your reputation being tanked, all for the sake of quote unquote speed. When if you had just taken some time to develop your sandbox a little bit more, you would have not been in that situation. A great example of this is Amazon's Kira agent. Back in, I believe this was in December last year. Yeah, December last year, yeah. They had this agent that they told it to do a simple bug just to fix something. And it decided the best course of action was to delete the entire production database and redo everything from scratch. I'm sure the engineer that did that thought he was the best prompter ever. And if Amazon, a multi-billion-dollar corporation, can make this kind of mistake, those are mistakes that we can make as well. They have lost a lot, 6.3 million orders, and there was a 13-hour outage just because the bot had way too many permissions. GoRabbit put out some reports saying that with AI agents, they're introducing about double the amount of bugs, double the amount of security flaws, and 8 times the performance issues on machines and databases. So we have to be very, very careful with how we do these things. So basically, the takeaway here is I think there's a way the agent will 1000% find a way. So just don't give it away at all. Lastly, this one is not as important, but I'm going to mention it anyway. So the metric you build determines the kind of like product you build. So if you are prioritizing how much code you can get out, let's say you're doing a consumer product and you need to be pumping out features every single day because you know OpenAI might do a Twitter post and your whole startup dies, so you have to be doing stuff all the time. You care about lines of code, and Striker would have worked perfectly fine for you. But if you're working in B2B SaaS, where, like I just said earlier, a mistake is a lost contract, it's your reputation, especially trying to get things off the ground, and the sales cycles are so long, you don't want it to be your agent that messes up, that costs you so much work and time. So just prioritize for what's actually important. For us, when we did Coder, we just wanted to give something that our engineers would be able to sort of, instead of replacing the engineer, we just want to give them a tool to make doing their job easier. And a big bottleneck that we had was context switching with all the different agents that were running at the same time, and Coder solved that issue. Essentially, I thought it was just like having another laptop. So I could have 10 Coder sessions going, and it would be the equivalent of me having 10 laptops and running the exact same things all at the exact same times. And when something is ready, all I need to do is switch tabs, look at the preview branch, everything is good to go, boom, PR is ready. So yeah, takeaways again. If there's a way, the agent will 1000% find a way. You can connect with me on LinkedIn. We're hiring for a lot of developer positions. But yeah, so any questions?
So hi, my name is Yesh. I work at Harmonic AI. I'm an AI engineer over there. And for those who don't know, Harmonic AI is a platform where we sell data to venture capitalists and other financial institutions alike. And we help them source, track, and evaluate companies for the sake of their investments or whatever interests them about this data. And one of the things that we built at Harmonic is our very own AI agent named Scout. Scout helps helps our customers basically query the data, research their thesis. It helps them create visualizations. You can think of it like Claude Code, but for their Harmonic workspace. And we'll get into what that means later on. So I want to begin with an experience we've all probably had before, and it's working with coding agents. And I kind of skipped it behind me, but I will be talking about how to build reliable AI agents with feedback loops. Now we can begin. So coding agents, I'm sure we've all used it. They're really magical. They get a lot of work done for everybody. There's a reason why Anthropic is at $30 billion revenue run rate right now. So that's just obvious. But why they're magical is because coding software, it's a domain that has a lot of feedback primitives. And what I mean by feedback primitives is this opportunity to really shed light on, hey, is the agent doing the thing correctly? It constantly can understand and steer itself without the human being in the loop to do that. And that's kind of hard in like other domains. But one thing that coding has shown me, and it's probably shown many of us, is the opportunity. Let me expand this graph a little bit. Sorry. Where's the cursor? All right. One thing coding has shown us is that you don't actually have to be in the loop for the simple tasks. Depending on the complexity of the task, you get the opportunity to use different feedback primitives to help steer the agent. So you make a simple script, it's able to use the type checker to verify, did this script actually like work? You are trying to create the next, coding agent. You're probably going to need some human feedback. So you have different feedback primitives for different task complexities. And that was like a really novel insight for us. Back. All right, so the key thing I want everybody to take away right now is that feedback loops are a way of context engineering. They're a way for agents to accumulate the information that they need during their runtime from the environment, from the user, whatever, such that it can actually accomplish meaningful work for the end user. And what I mean by reliability in this context is like accomplishing this work, fulfilling the task to you, the user, your expectation, or beyond. That would be the best outcome. And so for the rest of this talk, we're going to be just holding this definition in mind, that feedback loops, they're about context engineering and collecting the right information at the right time. And reliability means making sure that you, the user, are satisfied with the output from the agent. So something that we've come up with at Harmonic while building Scout was this framework of thinking about what kind of feedback loops actually exist. And it's three-tiered. We have the agent-facing feedback loop, user-facing feedback loop, and persistent. And we'll dive into what all of these mean right now. So the agent-facing feedback loop. So Scout, as I mentioned, it has this ability to query the data for the user using natural language. It's great to be able to find companies in New York that are currently hiring, but it's even better to find companies in New York that just recently raised, that have founders that went to NYU, that also graduated in like 2018 onwards. That's what Harmonic can provide. And expressing that intent using natural language is the perfect form factor for Scout to take that information and query our data for the user. Now, an agent-facing loop in this case would be Scout formulates a SQL query, pulls the data, and analyzes the first couple of results, and it's like, I think this is right. So it goes back and it changes the queries such that it actually gets the right information for the user. So that's the first kind, an agent-facing loop. The second kind is my favorite, is the user-facing loop. And this is like something I think is quite novel. Not all feedback loops are actually supposed to be for the agent. Some of them are supposed to be for you, the human. And so a really interesting example of this is Dev and Review, if people have used it. It is the opportunity to get like an AI agent to review your code and such that you can see the changes in the PR and you can separate it out, flag what information is like potentially dangerous. And it's really helpful information such that you can take action on that. So you get a better interface to interact with the agent, and you can feed that information back in the loop so you can get the agent to actually perform the task to your liking. And the last one hinges on memory, and I'm sure many people have experienced this. The beauty of skills, the beauty of Claude, remembering you tell it, I don't like this in a specific chat, and carrying that over to the next session. It's kind of the persistent loop. It is very, very interesting, but I think another talk is needed for that. So we're going to brush this to the side for now. Now, I would love to sum this all up in a cohesive example for all of you. Kind of gave a primer on what Scout is, the ability for our customers to basically find companies of their interest. So in this case, our customer is interested in early stage AI companies like Rippling. So they send that over to Scout. Scout formulates the SQL query, it finds the information. The agent-facing loop is able to retrieve some companies. It's like, not so right. The first shot, let me try again. Second shot, not there yet. Third shot, finally we get some information. We show the user a set of companies, right? Now, it's nice that with AI, it can streamline a lot of work for us. And sometimes that's really that's exactly what you want. But other times you kind of want a comprehensive set of information. If you're looking for companies, you kind of want more than just 10. And that was kind of one of the shortfalls that Scout had. It was so good at just picking out the top 10 that the users wanted, show me the next 100, show me the next 1,000. So I can go through and kind of sift through this information. Very below the line, as we say at Harmonic. So we listened to this feedback and we decided, okay, what can we do? Well, we can introduce a user-facing loop. This time, now when the user clicks an option to view all the results, we actually kick off Scouts in the background such that they can review these companies individually and check how many of them actually fit the user's specification, what would be interesting to them. And we rate them and rank them. And we show this information to the user with meaningful context, like their funding stage or their funding amount. And we also introduce a little description on why we think this company surfaced that high up. So this is really just to accumulate all this information together so that your feedback loops can really create an agent that performs work with to your expectation. Now, I want to make this practical. I don't want to brag about Scout. So how can you guys implement this for your own work? And I think it's really comes down to these 4 things. You're going to have to listen to your customers for their workflow bottlenecks. So what are they doing that's really tedious? You're going to have to analyze the data, see where your agents are messing up. For us, Scout constantly messed up on certain queries like finding stealth companies. We've introduced context such that it can help figure out what a stealth company actually is and use a feedback loop to figure that information out. Subsequently, you're also going to need to figure out what are these context primitives that can really drive feedback loops. In the domain of coding, that's really obvious. In the domain of searching for companies, less so. So that's why user-facing loops kind of come into play. presenting this UX to them that really drives this home. And the last is persisting feedback such that it can be remembered in later sessions. Now, it's really not, So it's really not that easy to design feedback loops. And I think that's something that I tripped on once I started drinking the Kool-Aid. And I was constantly thinking like, oh, this can be a feedback loop, this can be a feedback loop. And that didn't work out well for us. So some of the learnings that I took away is like, the most important thing is deciding what can be a feedback loop, because you have to consider latency, you have to consider token cost, you have to consider like making sure you don't rot your context. All of this is really important because you can just get your agent spinning in circles. And I'm sure that we've all experienced this with Claude at like a long session, and all of a sudden it's like not doing anything meaningful for you anymore, and you clear the session with the context window. So overall, my takeaway for this talk is to you guys is think in feedback loops. It's all about context engineering and making sure that you give the agent the right primitives such that it can accumulate this information right when it needs to. Thank you very much. I appreciate it. And like I said, I work at Harmonic. And if you're interested, we are hiring. So feel free to scan that QR code or find us at the back.